Welcome to AERO 2230, ProPilot 1, presentation number 5 on the flight environment. In this presentation, we'll be looking at airports and runway markings, airport signage, and also general flight rules that all pilots need to know to operate in the National Airspace System. We'll also discuss airspace, different types of airspace, the requirements for those airspace that you need to be aware of, and we'll also discuss air traffic control procedures. Airports with air traffic control towers are known as controlled airports. An ATC tower has control over all of the airspace surrounding an airport, usually within 5 miles, but sometimes more. Pilots are required to contact the tower by radio in order to enter the airspace. Towers control all flights within their airspace and on the ground. Non-towered airports are known as uncontrolled airports. There's no air traffic control tower, there's no air traffic control procedures. Safety is maintained by using standardized radio calls by pilots. Airport runways are numbered according to the direction that they point on the magnetic compass. For example, in this picture on the left here, there's an airplane approaching runway 33. Well, that runway is oriented to 330 on the magnetic compass. Runway designations change over time, though, due to the movement of magnetic north. So there may be times when a number on a runway is changed. It's important to always take off and land into a headwind as much as possible. Windsocks indicate the direction and velocity of wind at all airports. And you can also find out the direction and velocity of wind by tuning into an automated weather observation station, if there's one available at the airport you're landing at, or even a close by airport. Other wind direction indicators at airports include a tetrahedron and a wind T. You can also have these indicators located within a segmented circle. The standard traffic pattern at all airports is at 1,000 feet above the airport elevation. All turns in a standard pattern are made to the left, so you could say it's left traffic. Some non-standard patterns require right-hand turns or right traffic. And a segmented circle can show pilots in the air whether there is a standard or non-standard traffic pattern. There are 4 legs in a standard traffic pattern: the upwind leg, crosswind, downwind, base, and then final. Here's a depiction of a left-hand pattern, which is a standard traffic pattern. Notice that all turns are made to the left. Here's a depiction of a segmented circle. And as I said before, oftentimes you'll see wind cones or windsocks or tetrahedrons, other wind direction indicators inside of a segmented circle. And these indicators outside of the circle indicate the direction of the traffic pattern. Just think of this part of this indicator as being the base leg and this as the final. So for this runway that runs in this direction, this is left traffic. You would turn left to get to the final. If you were using this runway here, this would be right traffic. So this would be downwind, base, so you would be turning right on the final. Here are the different wind direction indicators that you'll see at different airports. Windsocks are very common. Less common are tetrahedrons, or what's called a wind cone, or even a wind T. Notice that the direction of the wind in this illustration is from right to left. So if the wind is moving from right to left in this illustration, the wind T would look just like that. So think of the wind T as an airplane. So the airplane is pointing into the wind. The tetrahedron, think of that as a rocket. The rocket's pointing into the wind. And the windsock is a little different. The wind always enters the large part of the windsock and exits the small portion. Again, the standard traffic pattern is a left-handed pattern that's depicted in this illustration. Notice the wind T. In this illustration, the tetrahedron indicates left traffic for runway 9 and right traffic for runway 27. Runways typically are designated with right traffic, which is non-standard because of obstructions, also because of potential conflicts with traffic on another close by runway. In this illustration, you've got two parallel runways, and because of that, the traffic pattern is left-hand on runway 9 left and right-hand on runway 9 right. Runways are marked according to the type of instrument procedure that's available at that airport to land on that runway. The runway on the right side is known as a visual runway. In other words, there is no instrument procedure available for that runway. The runway on the left has a non-precision instrument procedure. So it includes a couple more markings than the visual runway. And then the runway in the center is a runway that has a precision instrument approach procedure. And you'll notice that that has many more markings available. Now, we won't get into the difference between a precision and a non-precision instrument approach. That should be handled when you get your instrument rating, but just understand that that's the reason why these runways have different markings. So on a precision approach runway, you have threshold markers, you have a touchdown zone marker, an aiming point marker, in addition to the runway designator and the center line. Here's an example of a displaced threshold on the right side. Those arrows point to the threshold markers. It's important for you to understand that you are not supposed to land until you get past the threshold markers. These are the threshold markers here, and this is the displaced threshold. You can use that for taxi and for takeoff, but you cannot use that for landing. There are two types of displaced threshold markings. This on the left, these arrows indicate that you can use this for taxi and takeoff. In other words, you can use this to start rolling for your takeoff, but you can't land on it. You have to land beyond the threshold markings. These chevrons on the right side indicate that you can't use that for anything. You can't use it for takeoff, taxi, or landing. The picture on the left is a picture of a runway hold short line. Think of any sign or marking with a red background and white lettering, just like you would think of as a stop sign. You cannot cross this hold short line unless you have permission from air traffic control, unless you're cleared to cross it. On the right side, you see a black background with yellow lettering. That's a location sign. So this is taxiway Kilo. One very important sign to know is the sign for a closed runway. And that's sometimes painted on the runway as a yellow X, and sometimes you'll see a temporary sign like this that can be lit at night, showing a yellow X. That runway is closed, probably temporarily for construction or some other reason. So again, it could be either a temporary sign like the one we saw on the previous slide, or you could see yellow X's painted on the runway. So here we have two different signs. The one on the left is a location sign, and that tells you you're on taxiway alpha. The one on the right is a hold short sign. That tells you you're at the hold short line for runway 14. Here's a hold short sign for runway 9 and 27. Now in this slide you see the hold short signs, or what they call in this slide a mandatory instruction sign. You see the location signs, the black background with the yellow lettering. You also see a yellow background with black lettering. Those are directional signs. Those tell you what direction to turn in order to get to, for example, taxiway Echo, or to get to the international terminal. So think of yellow background, black lettering as a directional sign. One thing that every pilot should be familiar with is called land and hold short operations, or LASO. An airport with land and hold short operations is usually a busy airport that has intersecting runways. Sometimes they have a busy taxiway intersecting with a runway. And the reason for land and hold short operations is to keep traffic moving as much as possible. So at an airport that has land and hold short operations, when you are cleared to land on a runway, the air traffic controller will tell you that you're cleared to land on runway, for example, runway 33, land and hold short of runway 23. And it's your responsibility as the pilot to respond cleared to land runway 33, hold short runway 23, and then proceed as instructed. It's important to remember that as a private pilot you are not obligated to accept land and hold short operations if you feel that you cannot accomplish it safely. Also, it's important for student pilots to know that student pilots cannot accept land and hold short instructions. One thing that you'll see at many airports are visual approach glide path indicators, and they're lights positioned next to the runway to tell pilot whether they are too high on final approach, whether they're too low, or whether they're right on the glide path. What you see pictured here is called a VASI, or a visual approach slope indicator, and that is two lights basically, red and white. If you see two red lights, as in the left, that means you're too low and you need to climb to intercept the glide path. If you see two white lights, as in the picture on the right, that means you're way too high. You need to descend to intercept the glide path. When you see red over white, that means that you're right on the glide path. Another visual approach glide path indicator is known as a PAPI, or a precision approach path indicator, and that includes 4 lights. The 4 lights can either be red or white. When you see 2 white and 2 red next to each other, as in the upper left hand side of this picture, that means you're right on the glide path. If you saw 4 red, that means you're too low. 3 red and 1 white means that you're slightly low. Again, 2 red, 2 white means you're right on the glide slope. 3 white, 1 red means you're slightly high, and 4 white means that you're too high. VFR pilots, or pilots who fly under visual flight rules, are responsible for see and avoid. What see and avoid means is that the pilot, the PIC, is responsible for scanning for traffic and avoiding other traffic. Even if the pilot has contacted air traffic control and they've agreed to give the pilot traffic advisories, ultimately it is the responsibility of the pilot to see and avoid. So it's very important for pilots to develop a scanning technique, and one recommended technique is to scan in 10-degree increments. So for example, start on your left side and scan, and then move to the right 10 degrees, scan, move to the right 10 degrees, scan. If you're getting traffic advisories from air traffic control, you may hear them say something like traffic 2 o'clock, 1 mile westbound. They're telling you to look at the 2 o'clock point for the traffic and then advise them when you have it in sight. One thing to remember though is you may be crabbing into the wind in order to maintain a track. If that's the case, as shown in this illustration, 2 o'clock to the controller is actually 3 o'clock to you. So what can we do as pilots to make sure that we are seen so that we can be avoided by other pilots? Well, we can bank our airplane if we are trying to be seen by another pilot, or we could use our landing light, especially near airports, even in the day, to increase our own visibility. We can make clearing turns, especially before doing maneuvers in an area, in order to clear the area of traffic. One common way to clear for traffic is to make a left 90-degree turn and then clear, and then another right 90-degree turn, and just make sure that the area around your aircraft is clear of other traffic. It's important to remember that every aircraft has blind spots. As you can see, you have two airplanes approaching to the same runway in this picture. The one below cannot see the aircraft above. So again, it's very important to maintain situational awareness about the traffic around you. One way is to make sure that you are looking for other traffic, scanning for other traffic, and also talking on the radio to other pilots. Just like driving a car, aircraft are required to abide by what we call right-of-way rules. And the primary right-of-way rule is that the less maneuverable aircraft typically has the right-of-way. So a balloon is less maneuverable than an airplane. A glider is less maneuverable than an airplane. So a balloon and glider has the right-of-way over an airplane. Remember, an airplane in distress, or an airplane that has declared an emergency, has a right-of-way over all of the traffic. That's the only exception. Remember, if you are trying to determine whether or not an aircraft is converging with you or will conflict with you in any way, use the navigation lights to determine which way the aircraft is moving. Sometimes it's very difficult to see. Remember, the green light is on the right wing, and the red light is on the left wing. And the white light is on the back of the airplane. So if you see a white light, that airplane is moving away from you. If you see a green light, then what you're looking at is the right wing. So if you see the right wing, that means the aircraft is passing you or crossing your path from left to right. If you see a red light, that means you're looking at the left wing. So that means that airplane is crossing your path from right to left. If you're converging or overtaking another airplane, the rule is pass the other airplane on the right. So if you're overtaking another airplane because you're faster, pass the other airplane on the right side. If you are head-on with another aircraft, each of you should turn to the right to avoid collision. And if you're converging on another aircraft, as is shown at the bottom of this illustration, then you should pass behind the other aircraft. Rules for minimum safe altitude depend on the area that you're flying over. The rule for a congested area is to maintain at least 1,000 feet above the highest obstacle and horizontally 2,000 feet. In an uncongested area, the rule is a little less stringent. You need to maintain at least 500 feet above the ground. And in a very sparsely populated area, The rule is 500 feet from the highest obstacle. Now, we not only need to be concerned about the wind when we're landing and when we're flying an airplane, we also have to be concerned about the wind when we're taxiing. If the wind is very strong and we're dealing with a crosswind, it could affect our ability to taxi the aircraft, and if the wind's strong enough, it could actually flip the airplane or cause the airplane to maybe strike a wing. So it's important to know how to position your controls when you're taxiing in a crosswind. If you're taxiing in a tailwind, the term to help you remember how to position your controls is dive away. So you want to position your elevator with full forward pressure on the yoke or the stick, and you want to turn the yoke or the stick away from the wind. So if the wind is coming from the left, you want to turn your yoke or your stick to the right. So you're diving away. It's the opposite if you have a headwind. If you have a headwind from the left, then you want to remain neutral with the elevator, and you want to turn your yoke or your stick into the wind. When you're flying with another pilot or with an instructor, it's important for both of you to understand who is actually controlling the airplane. If you want to take controls from the other pilot, there is what's called a positive exchange of controls procedure. That's where you, as the pilot taking control, states, "I have the flight controls." The other pilot should restate, "You have the flight controls." And then you should, a second time, say, "I have the flight controls." And then just confirm that you are actually controlling the aircraft. Now, if you're going to an unfamiliar airport, it's important for you to learn as much as you can about that airport. For example, you need to know the runways, the runway lengths. You need to know any other information, radio frequencies, for example, if there's a tower, whether fuel is available. And you can find all of that out in the chart supplement. This slide's labeled Airport Facilities Directory. It used to be a separate document that was published every so often. Now it's called the Airport Chart Supplement. Very important to get to know the supplement, where to find the different information that you'll need to know when you're going to an unfamiliar airport. So again, air traffic control, ATC facilities exist at controlled airports. You'll have a tower. You'll also have approach and departure control at some of these airports. You may not at a Class Delta airport have any kind of approach or departure control, but at a Class Charlie or a Class Bravo airport, you will have a separate approach and departure control. And then you'll be handed off after you leave an airport, a controlled airport, you'll be handed off to an en route controller, maybe a center controller. TRACON stations, TRACON stands for Terminal Radar Control Stations, exist all over the country, usually around bigger airports, Class Charlie, Class Bravo airports. This is a map that shows all of the TRACONs around the United States. And then you have air route traffic control centers. Centers control a larger area. For example, you have the Indianapolis Center, the Memphis Center, Atlanta Center. They usually control traffic above a certain altitude. Remember, pilots are required to use the phonetic alphabet when communicating with air traffic control. The reason we use the phonetic alphabet is because many of the letters that we state on the radio sound the same. For example, the letter M, or Mike, sounds the same as the letter N, or November. Pilots communicate with air traffic controllers in a couple of different ways. The first way is with radios. Pilots use very high frequency or VHF radios. One thing to remember about VHF radios is they're limited to line of sight. That means if there are any obstructions like mountains or big buildings between you and the receiving antenna, you may not be able to contact the controller. As altitude increases, though, radio range also increases. The other method we use to communicate with air traffic control is through the transponder. And on the right here, on the lower right side, you see a picture of a transponder. It's a digital transponder. Some older airplanes may have analog transponders. But you'll see 4 numbers on the transponder that you can change. Those are called squawk codes. The squawk code for a standard VFR flight is 1200. So if you're just flying VFR, you're not contacting ATC, it's important for you to squawk 1200 in your transponder. When you're flying in Class Delta, Charlie, and Bravo airports, you want to make sure that the transponder is set to the correct code. It's a 4-digit code, but the numbers are limited to 7. Now, there are special transponder codes you want to use in special circumstances. For example, if you're experiencing an emergency, you should set your transponder to 7700. If you've lost your radios, your VHF radio is no longer working, and you can't contact ATC, you should squawk 7600. And if you've been hijacked, the squawk code is 7500. Pilots are required to communicate with air traffic controllers using proper phraseology. It's like a different language, but it's not difficult to learn. The general rule of thumb is to keep your communications as brief as possible to avoid overcrowding the radio frequency. In this example, the pilot is contacting the ground controller to get clearance to taxi. And he starts by saying, "Ground, November 1234, ready to taxi from the GA ramp with Bravo." So he's identified himself as November 1234. That's his tail number. He's told the controller where he's located at the GA ramp, or the general aviation ramp, and he's told the controller what he's requesting to do. He's ready to taxi, and he has information Bravo. That's the information that he's received before he contacts the controller by listening to the automated terminal information system. The controller then responds, November 1234, runway 27, taxi via Alpha, hold short of runway 31. So the controller has given him permission or cleared him to taxi to runway 27 via taxiway Alpha, but he is to hold short when he gets to runway 31. The pilot needs to read that back to make sure that the controller knows that he understood the instructions. So the pilot responds, November 1234, runway 27, taxi via Alpha, hold short runway 31. And then when the controller is ready to clear the aircraft to cross the runway, the controller will say November 1234, cross runway 31. If you'll be flying an aircraft with the G1000 glass panel, like the Diamond DA40 at the MTSU Flight School, you'll need to learn how to dial in the correct frequency on the radio and how to toggle the inactive frequency to the active frequency, and also how to enter in the correct transponder code. The radio frequencies, the communication radio frequencies, are on the upper right hand corner of the primary flight display. The transponder is on the lower right hand side. So if you're new to speaking on the radio, you're probably nervous about it, you may hesitate, but know that everyone has to learn, and ATC understands that there are pilots who are new student pilots who need help every once in a while. The best thing for you to say before you contact air traffic control, or when you're initially contacting air traffic control, is to tell them that you're a student pilot. That way they'll be a little bit more tolerant about mistakes, and they may even help you through a communication. One way for you to learn proper phraseology is to listen to actual air traffic control frequencies on liveatc.net. That's the end of Presentation 5 on airport operations. The next presentation will be on airspace, and that will be the last presentation for Module 1.